Hello everyone, this is Darren from CYP PD1. Today we'll introduce AV over IP. We call this system is CDM, Channel Distribution Master. Today I'm going to explain how the AV over IP works. First, I will explain the concept of AV over IP. Second, I will describe the framework of operation. Then we will use an application case to demonstrate how the IP system is actually used in the market and the product spec. Finally, I will explain the difference between the type of video codec. We know that the AV over IP refers to the transmission of video and audio content over IP. It can convert the video and audio data from camera, laptop, or multimedia player into IP data packet and sent through a network switch. The display device can obtain the required video from the network switch and convert it to a video interface support. It's important to know that video input only needs to be done once. However, the IP architecture, the receiving end can be multiple devices, and this device can obtain the same video from the network switch at the same time. In traditional Pro AV system, this kind of AV system behavior is called matrix. The main behavior of AV over IP is to transmit video and audio under the IP system, but in different applications will be used other interface for scenario. For example, USB can be used in the conference with USB camera. H.264 can be used for the live streaming application. Of course, each space will be used control system to link each peripheral. PoE can also get power from the network switch through the cable, thus simplify the connection of the system diagram. Now, take the actual application case of 1G AV over IP for easy to know how to use in commercial. This is in the case of a sport bar. There are 8 sport programmers need to be delivered to 30 monitors, and the function of the TV wall will be used. This is a whole view of the application, actually divided into several small areas. Customers in each area can switch their content, so the sports can switch instantly. You can see the single transmission from the system diagram. The left side is the video source, the right side is the monitor, and the middle is the switch. Because this system using network protocol, each point-to-point distance can reach up to 100 meters. In other words, the distance from the video source to the switch is 100 meters. The switch to the display also 100 meters, and the total is 200 meters. Under the network protocol, the encoder is sent to the switch by multicast, and the decoder requires the video from the switch. Under the structure, this function is the same of the video matrix of the Pro AV, and the decoder itself has the function of the TV wall, and can process the video segmentation of the TV wall. The entire system can be easily set up and controlled with only one controller. The AV over IP controller just mentioned can be used with the touchscreen for real-time operation. The next video is the sport bar to real-time switching content. On the screen left side is the video source and preview the encoded content. On the screen right side is the monitor and also preview the content of the decode. Through the control screen, you can easily to routing the content to monitors. In addition to the enter AV over IP equipment, CIP also provides a dedicated CSU cabinet, can be concisely placed in a standard cabinet. The product used in this application is 1G AV over IP and support 4K30 resolution. At the same time, there is also a LAN hub that can transmit control signal, and the device itself also supports PoE PD to achieve no additional connection to the power supply. USB interface can support USB KVM function. RS-232 and IR interface can also accept traditional control signal. As for the controller, HDMI and the USB interface can be connected to the touchscreen for UI control. And there are dual network cards that can separation AVoIP string between standard internet for bandwidth congestion. Finally, I will introduce the difference between CYP AVoIP codec. When we talk about IP, the first thing is the bandwidth. At present, a CDM codec would be the maximum bandwidth used by Cypress. Product which require the bandwidth of 9G to transmit 4K 30 resolution. The codec in the sport bar application case only required a bandwidth of 300 Mbps to transmit the same resolution. The H.264 and the 5 codec transmit the same resolution use less than 30 Mbps. To transmission the same resolution over low bandwidth, infrastructure compression is required. The main downside of compression is a loss in video quality. There is a value used to analyze video loss, naming PSNR. When the PSNR is 100 dB, it means that there is no pixel loss. The smaller the value, the greater the loss. It can be seen from this table at SDView using the bandwidth range has no loss at 4K30. This is because 4K30 can transmit at 9 Gbps bandwidth without compression. When the resolution reaches to 4K60, should be slight compression and the PSNR is reduced to 70 dB. The 1G AVoIP used in the sport bar application case use motion JPEG codec, and that use 30 times compression for the 4K30 resolution, and the PSNR to be reduced to the 45 dB. The codec is H.264 and 5. This codec is more commonly used in the security industry, with a compression rate up to 300 times, and of the PSNR drop to about 30 dB. The highest latency is H.264 and 5. This codec is widely to use in security, and the camera between command room distance is very long, so the latency is not the most important priority. But smaller the bandwidth, the more camera you can use. Thank you.